warehousing and store management. Warehouses are commercial buildings for storage of goods. They are used by manufacturers, importers, exporters, wholesalers, transport businesses, customs, etc., and are essential for storage of industrial goods. In this lesson, we will discuss warehousing and store management in terms of a physical job as well as the managerial task. It follows from the previous slide that after studying this lesson, you should be able to understand the meaning of warehousing, understand the benefits of warehouse management, define warehouse strategy. Since early times when the manufacturing started, manufacturers were able to recognize the fact that customer needs need to be fulfilled as soon as he is asking for the product in order to retain him. Yet, warehousing capability used to group products into assortments desired by customers was given little emphasis. There was a lack of concern with material handling principles. But increased business complexities, consumer demands, and competitive capabilities have compelled the businessmen to emphasize on improving storage and handling effectiveness in modern times. A warehouse provides two basic types of benefits, namely economic and service. While economic benefits include consolidation, break bulk, and cross-dock, processing or postponement, and stockpiling, etc., service benefits include spot stock, assortment, mixing, product support, and market presence. The main factors to be considered in the design process are the number of stories in the warehouse, height utilization, and product flow. On the basis of these, we determine the design criteria, handle technology, and develop our storage plan. In designing a warehousing system, the basic questions to answer are: how many warehouses should we have? Where should we locate them? What should be the size or capacity of each one of them? The ideal warehouse design is limited to a single story so that product does not have to be moved up and down. The second principle focuses on the effectiveness and efficiency of material handling technology. The elements of this principle concern movement continuity and movement scale economies. According to the third principle, a warehouse design should consider product characteristics, particularly those pertaining to volume, weight, and storage. Product volume is the major concern when defining a warehouse storage plan. A private warehouse facility is owned and managed by the same enterprise that owns the merchandise handled and stored at the facility. A public warehouse is operated as an independent business, offering a range of services such as storage, handling, and transportation on the basis of a fixed or variable fee. Contract warehouse combines the best of both private and public warehouse. The long-term relationship and shared risk will result in lower cost than typical public warehouse arrangement, although minimum fixed assets are required for facilities. Business firms utilize a combination of private, public, and contract facilities in order to make the system more efficient. This results in presence synergies, meaning the marketing benefits of having inventory located nearby in a building that is clearly affiliated with the enterprise. Industry synergies that refer to the operating benefits of collocating with other firms serving the same industry. Operating flexibility that refers to the ability to adjust internal policies and procedures to meet product and customer needs. Location flexibility, which refers to the ability to quickly adjust warehouse location and number in accordance with seasonal or permanent demand changes. And scale economies, referring to the ability to reduce material handling and to storage through application of advanced technologies. One of the most important functions in logistics is that of material handling. Though material handling cannot be avoided in the performance of logistics, it should, however, be minimized. Over the years, a variety of guidelines have been suggested to assist management in the design of material handling systems. The most important of them are: equipment for handling and storage should be as standardized as possible. When in motion, the system should be designed to provide maximum continuous product flow. Investment should be in handling rather than stationary equipment. Handling equipment should be utilized to the maximum extent possible. In handling equipment selection, the ratio of dead weight to payload should be minimized. Whenever practical, gravity flow should be incorporated in system design. Handling systems are classified as mechanized, semi-automated, automated, and information-directed. While mechanized handling systems are the most common, use of semi-automated and automated system is rapidly increasing. One factor contributing to low logistical productivity is that information-directed handling has yet to achieve its full potential. Material handling equipment is all equipment that relates to the movement, storage, control, and protection of materials, goods, and products throughout the process of manufacturing, distribution, consumption, and disposal. Forklift trucks, walkie rider, pallet trucks, tow lines, tractor-trailer devices, conveyors, carousels, pick-to-light system, semi-automated handling, automated guided vehicle system, sortation, robotics, and live racks are some of the handling equipments used in logistics. They are required to increase throughput, control costs, and maximize productivity. The appeal of automation is that it substitutes capital investment in equipment for labor required in mechanized handling systems. In addition to using less direct labor, an automated system operates faster and more accurately. Its shortcomings are the high degree of required capital investment and the complex nature of development and application. To date, most automated systems have been custom designed and constructed for each application. An order selection system is disclosed together with a method of operating the system for retrieving multiple types of items stored in pre-selected storage locations and delivering retrieved items in an orderly sequence to a plurality of packing stations in accordance with the specific requirements of different orders. The order selection system comprises a dispenser, a conveyor, a dispensing control system, a sorter, a plurality of stacking devices, and identifying means to identify the end of each order. The concept of automated unit load handling using high-rise storage has automated storage and retrieval systems, or ASRS, offer incredible cycle time improvements in operator efficiency and storage capacity, reduction of work-in-progress inventory, and improvements in quality and just-in-time performance. The concept of information-directed handling is relatively new and is still in the testing process. The idea is appealing because it combines the control of automated handling with the operational flexibility of mechanized systems. Now let us see how much you have understood. State whether the following statements are true or false. Distribution center is the space that can be leased to solve short-term distribution needs. True or false? False. This statement is false. The space that can be leased to solve short-term distribution needs is known as public warehouse. ASRS stands for Automated High-Rise Storage and Retrieval Systems. True or false? True. Last sentence says that shipping consists of primarily checking orders onto transportation vehicles. True or false? False. Let us take a brief revision of what we have studied in this lesson. Warehousing refers to storing of the goods on large scale in a systematic and orderly manner from the time they are produced until they are consumed. Warehouse operations are becoming more and more complex. The warehouse control system integrates the various functions and enables a better product flow. The managerial question to consider is whether a specific handling system should be designed on a mechanized, semi-automated, or information-directed basis. The initial cost of an automated system will be higher than for one that is mechanized. An automated system will require less building space, but the equipment investment will be greater. The key benefit from automation is reduced operating cost. An automated handling system, if properly designed and controlled, should outperform a mechanized system in terms of labor, damage, accuracy, product protection, and rotation. In the final analysis, the design to be used must be evaluated on the basis of return on investment.